Republic 2.0, and today we're going to do the May 2025 IAL Edexcel International Physics Paper 1. So in the Unit 1, we have got the first 10 multiple choices. In this part of the video, we'll try to solve the first 10 multiple choices. You've got this question number 1. A cube of volume V is placed in a liquid of density ρ. The cube displaces the weight of the liquid. Which of the following gives the magnitude of the upthrust acting on the cube? So we just need to talk about that. How can we calculate the magnitude of the upthrust? So, if you have done chapter number 2, you must know that the upthrust acting on a body is an upward force exerted by a liquid onto a body. And that would always be equal to the weight displaced of the liquid in which you have immersed the body. So you can see that the weight of the liquid which was displaced was W. So what does that mean? That the upthrust would also be equal to W. So that is going to be the right answer. Now you've got this question number 2. A seesaw is a uniform beam that balances on a support. The beam can rotate around the top of the support. Two children of equal weight. If they do have equal weight, what does that mean? That the downward force exerted by this girl should be equal to the upward force exerted by this boy. So what does that mean? That the summation of the forces, the resultant forces, has to be 0. And they're also at equal distances. If they're at equal distances, their moment would be the same as well. But the resultant moment has to be 0 because this one has to be counterclockwise and this one has to be clockwise and this one has to be counterclockwise. So the resultant moment comes out to be 0 as well. That is why for this multiple choice, we're going to go with A. Now you've got the diagram shows ball of mass moving at a speed v along the horizontal table. And then you have got a ball of mass 2m and 2p. Which of the following gives the time taken between the second ball leaving the double table and landing on the floor? So we need to calculate the time, and I would be using the equation of motion, the second equation of motion, which says that S is equals to ut plus half at square. So the distance, I can keep the distance to be the height. So I'm just substituting it with height. The initial velocity of the ball has to be 0. So 0 plus 1 by 2 gt square. From this expression, t square should be equal to 2h upon g, meaning thereby t is equal to the square root of 2h upon g. What does that mean? That the time would always be the square root of 2h upon g. So it is not affected by the mass, it is not affected by the velocity. It is just affected by the height and the gravitational acceleration. So t comes out to be 2h upon g. So whatever the time was taken by the first ball, the same time would be taken by the second ball if you've got the height same. So yeah, we're going to go with the option number B. Now you've got this question number 4. The forces acting on a person sitting on a chair are weight and normal contact force. Which of the following gives a reason why these forces do not form a Newton's third law pair? So first of all, the chair is stationary. Well, whenever Newton's third law pair of forces act on a body, the body has to be at stationary. So that is why you cannot go with the option number A. The force is acting in the opposite direction. Whenever the Newton's third law pair forces are acting, the forces must act in opposite directions. This is not also true as well. The forces act on the same object. Well, that is wrong. Remember that for the Newton third law pair, the forces must act on different objects. So this is right. This is not these kind of forces are not going to form the Newton's third law pair. So this is the right answer. And D, the forces have the same magnitude. Well, even if you're talking about the Newton third law pair, the forces should have the same magnitude. So that is also a condition for the Newton third law pair. So that could also not be the answer. Now, a wire is hung from a picture from a hook on a wall. The wire exerts T1 and T2 on the picture, and you need to describe the relationship between the forces. So if you're talking about the relationship between the forces, the weight must be equal to negative T1, negative T2. Weight is acting downwards and T1 and T2 are acting upwards. That is why I'm taking their negative signs into consideration. Okay. So by arranging this equation, I can have W plus T1 plus T2, and that must be equal to 0. Okay. Is that clear? So you have got the B part as the right answer. Okay. Now you've got this question number 6. An object has a constant non-zero acceleration. Which of the following displacement time graphs could represent the motion of an object? First of all, for this question, you must know that how you talk about the displacement time graph. Well, remember that displacement time graph, basically, you can calculate the velocity by calculating the gradient. The gradient would get you the velocity. You can see that in the option number A, the body has a constant gradient. So what does that mean? The velocity would be constant, so acceleration has to be zero. So A cannot be the answer. If you look into B, similarly in the B as well, the body's velocity is decreasing at a constant rate. So this acceleration would also be equal to zero. Over here, the acceleration would be equal to zero as well in this part, right? So the only way you can see that the bodies have a constant gradient over here and then a constant gradient over here. So it is a positive velocity. Over here, the velocity must be decreasing. So that is why we must be having a non-zero constant acceleration for this one. Now for the question number 6, you have got the forces acting on the helicopter are shown, 500 upwards, 15,000 downwards, 200 to the forward. Resultant forces. So, if you want to calculate the resultant forces, first of all, you need to talk about the forces, the resultant forces acting along the y-axis. And that must be 15,000 minus 14,500 square plus 200 square. That is how you'll calculate the resultant forces, and that must be it. So the final option going to be the B part. Now, if you've got this question number 8, a box of weight slides down the ramp, right? A box of weight slides down the ramp. The ramp is at an angle theta to the horizontal. Frictional force effects on the box is shown. Which of the following is correct when the box moves at a constant speed? If the box is moving at a constant speed, the force acting in this direction must be equal to the backward resistive forces. So what does that mean? This has to be the perpendicular component of weight, meaning thereby W sine theta. So F must be equal to W sine theta so that this box can move down at a constant speed, right? So that is why I'm going to go with the option number C. Now you've got this question number 10, and we need to calculate which the following expression gives force in newtons. So we need to calculate the force. If you remember a formula, power was equal to F times V, right? And if you are looking for the force must be equal to P upon V. You have got the power and you have got the distance and time for the velocity. So I'm just going to plug their values in. The power must be 50 times 10 raised to the power of 3, and the velocity must be 13 divided by 2.3. This 2.3 could get into the numerator. So 50 times 10 raised to the power of 3 times 2.3 divided by 30. That is how you'll calculate the final force. Is that clear? At the end of the day, you've got this question number 10, and you've got the 3m, you've got this truck is moving with a velocity v. This is the mass of m truck. The velocity is 2v. And we need to, which is the following expression gives the new speed of the train and truck, right? So, first of all, the initial momentum of this object, let it be 3mv. Now, since this truck is moving in the opposite direction, this should be minus 2mv. And after the collision, they move off together. So the velocity must be the same, but their masses must be 3m plus m times v. So 2mv minus 2mv must be mv is equals to 4mv. That is the final velocity, v hash, I can call it. And then v hash comes out to be mv divided by 4m, and that should be v by 4. So A is the right answer. So, in this part of the video, we're done with the first 10 multiple choices. In the next video, I'll be able to do the questions from 11 onwards. Thank you very much. Please share and subscribe the channel. Thank you very much. We've got this question number 11. A resultant force of 4,800 Newton acts on a boat. The acceleration of the boat is 0.31. We need to calculate the weight. So this question is quite easy. So, according to the second law of Newton, the resultant forces acting on an object is equal to mass times acceleration. For the weight, we need to calculate the mass. So the mass from this equation would be equal to the resultant forces divided by the acceleration. The resultant forces acting on this object are 4,800 divided by the acceleration is 0.31. So when you're going to divide them up, you would be having something like 15,500 kilograms. That is going to be the mass. After calculating the mass, you can easily get the weight as well because the weight is m times g. So W comes out to be 15,500 times 9.81. So when you're going to times them up, the final answer that you would be having is 152,000 newtons. So that is how we're going to calculate the weight for this question. And now we've got this question number 11. A person rides a bicycle along the path shown. It starts from here and end over here. At the end of the path, the magnitude of displacement from the start is less than the distance traveled by the person. It is less than the distance traveled by the person. Describe why the displacement is less than the distance traveled by the person. So everybody knows that, displacement has to be less than the distance. This is a 2-marker question, so we need to at least write down 2 points. So first of all, you need to mention that whenever you talk about displacement, the body covers displacement in a straight line, right? Displacement is always in straight line, right? Displacement is always covered in the straight line. But on the other hand, whenever you're talking about distance, it is just the length of the path between 2 points. Displacement is the length of path between 2 points. What does that mean? That if you're talking about the distance, you need to cover this path, right? And if you're talking about the displacement, you just need to cover this straight path. So, just use your common sense. So displacement has to be less than the distance, right? Because of this observation. So now, after this thing, we have got something like this thing. You've got the velocity time graph for the part of a bicycle ride is shown, something like this. And it is a VT graph. We need to calculate the maximum acceleration. So first of all, remember body is covering acceleration in this part from O to A. Body has some acceleration from A to B as well. And body has some sort of deceleration from B to C. And by just using your common sense, the greatest magnitude of the gradient is from O to A, right? So whenever you're talking about the acceleration, whenever you're talking about the maximum acceleration, you need to take the acceleration of this part. And the rest of the thing you already know. If you want to calculate the acceleration, it has to be the gradient of VT curve. It has to be the gradient of VT curve. So that is how we're going to talk about the acceleration. And whenever you want to calculate the acceleration, it has to be change in y upon change in x. So you can see that if you're talking about this point, the y coordinate has to be something like in between 6 and 4, that has to be 5. And the y coordinate over here sounds like something like 1.8, if I'm not wrong, right? So, you've got y2 and y1, and that has to be 5 minus 1.8 divided by x2 minus x1. So if you look over here, the x2 has to be something like this is going to be 15, then this is going to be 16. So you have got 16 x2 and x1 is going to be something like behind 5, that has to be 4. So by just solving this thing down, you'll have the maximum acceleration of an object, and that has to be 0.267 meters per second square. So that is how you're going to calculate the maximum acceleration. The main point is that whether you'll be able to determine that in which part out of OA, AB, and BC, the body would be having a maximum acceleration. Now you have got this question number 13. In a game of basketball, points are scored by throwing a ball so that it falls through the hoop. The rule states that the distance between the hoop and the floor, this horizontal distance between the hoop and the floor, which is going to be this distance, right? The vertical distance, D, should be 3 meters. The basketball player throws the ball so that it falls through the hoop as shown. When the ball was thrown from a height of 1.7 meters, so the initial height was already given and that is 1.7, right? So you've already got this height, 1.7. The initial vertical component of the velocity is 5.1 meters per second square. The final vertical component is 2.1 meters per second square, and deduce whether the d was 3 or something else. So, we just need to work these things down. So to calculate the total distance from the above height to the hoop, I'm going to use the third equation of motion where v square is equal to s square. V square is equals to u square plus 2a or g times s. Since we're looking for the distance, so it has to be something like 2gs is equals to v square minus u square. And s comes out to be v square minus u square divided by 2 times g. Now, what was the final velocity? Since that velocity would have been downward, so I'm going to take it as a negative velocity. And the final answer that I could have from here has to be something like minus 2.1 square minus 5.1 square divided by, since the ball is moving up, the gravitational acceleration has to be negative 9.81. And when you're going to simplify this down, the distance that I would be having is going to be 1.1 meter. So total height of the hoop above the flow has to be 1.7, which was the initial height, plus 1.1, which comes out to be 2.8. And since 2.8 is not equal to 3, so the claim is not right, right? We just needed to deduce that whether the d would be 3 or not. And that is how we're going to deduce that d is going to be 3. Now we have got this question number 14. You have applied the brakes in the car reduce the kinetic energy. In an electric car, some of this energy is transferred to the battery of the car. So what does that mean? That the input has to be the change in the energy, and the output has to be the energy transferred to the battery. So you've got this you've got this mass, you've got this speed, and you can calculate the kinetic energy, and it's going to apply some brakes. The vertical displacement of the car is 0.76, right? And the energy stored in the battery is going to be 45 kilojoules. So that has to be input from the given data. And how would you calculate the output? First of all you need to do is to calculate the kinetic energy, and that has to be 1 by 2 mv square. So half times 1800 times 14 square. And when you're just going to simplify this down, after simplifying it down, you must be having something like 176,000 joules. And whenever you're talking about the gravitational potential energy, it has to be mgh. Whenever you're talking about the mass is 1800 times 9.81, and the vertical distance they covered was 0.76. You're going to times them up and you would be having something like 13,400 joules. So if you want to calculate the efficiency, it has to be input, which was output. This is going to be the output because that is the energy transferred to the battery. So 45 times 10 raised to the power of 3 divided by the difference, the change in the energies. And that has to be 176,000 minus 13,400. So the efficiency comes out to be, 45 times 10 raised to the power of 3 divided by whatever this gives you, 176,000 minus 13400. And when you're going to divide them up, you would be having an efficiency of about 0.27. So that is how we can easily calculate the efficiency. Now, we've got this force extension curve, and we need to determine the increase in the elastic strain energy in the brick as the force increases from 85 to 140. So what does that mean? First of all, point out the 85. So 85 must be, somewhere, I'm just taking a hand guess. 85 must be somewhere over here. So the area covered under this part of the triangle, that has to be the force extension curve. And the other thing is 140, right? So you've got 140 somewhere over here. And if you're going to calculate the total area up till 140, that has to be this one. But we're just looking for this area, right? So we're going to calculate the total area for the triangle of 140 Newton. And then we're going to take it away from the triangle of 85 newtons, right? And if you're talking about the compression, compression is just being a bit misplaced. Remember that, I've taken the data from another paper. The compression over here has to be something like 97. And if you talk about the compression over here, the compression over here has to be something like 60, right? So you can just simply calculate the change in the energy. Yeah, the energy stored between 85 and that thing. So the elastic potential energy has to be something like 1 by 2. First of all, 140, the extension is 97.5. It was nanometers, so 10 raised to the power minus 9. This is the total work done up till 140. You need to take it away from 1 by 2 times. The other thing is 85 times 60 times 10 raised to the power of negative 9. So you just need to, subtract them up, and you'll get the final kinetic energy that comes out like 4.28 times 10 raised to the power of negative 6 joules, right? That is how you talk about the elastic potential energy stored between those 2 points. Remember that that is not a triangle. So you need to calculate the area under the smaller triangle, the area under the bigger triangle, then subtract them up, and then you'll get the area in between them. The last question of this part, the bricks undergo the elastic deformation. What is meant by the elastic deformation? Such deformation in which a body can regain its original shape. Such deformation in which body can regain its original shape after removal of force, right? Even whenever you're going to remove the forces, the body will, regain its original shape. So, I've done all the questions related to mechanics in Unit 1. In the next video, I'll come back to you guys with all the question on materials. Thank you very much. So we've got this question now. And a student used a falling ball method to determine the viscosity of the vegetable oil. He measured the diameter of a ball bearing. He dropped the ball bearing into a measuring cylinder containing the vegetable oil, blah, blah, blah. The ball bearing reached the terminal velocity. The student then measured the time taken and the ball bearing. So you've got the time, you've got the distance, and you've got the diameter as well. Now you need to determine the viscosity, right? If you all remember, the formula for the viscosity, whatever we're going to use, is going to be the drag force equals to 6 pi eta RVT. So if you look into this formula can also be written as the drag force, which should be equal to the weight displaced of the liquid, 6 pi eta RVT. So from this formula, you can calculate the terminal velocity if you've got the time and the distance. You can calculate the radius from the diameter given above. The only thing that you do not have, G and pi are the constants. So the only thing that you need to measure is the mass of the ball bearing. So the only thing that we need to measure is the mass of ball bearing. That is what we need to look for. Now in the B part of this question, you need to calculate the diameter of the ball bearing. And it was 1.24 millimeters. So what does that mean? That the radius has to be 0.62 times 10 raised to the power of negative 3 meters. The time taken to fall is 20 centimeter was 1.3 seconds. What does that mean? That the terminal velocity has to be 0.2 divided by 1.3, whatever it comes out to be. And then at the end of the day, we've got the drag, and that comes out to be 5.6 times 10 raised to the power of negative 5 Newton. So by using the same formula that the drag force is equals to 6 pi eta RVT, we can calculate the eta, and the formula for the eta is going to be FD divided by 6 pi R times VT. Is that clear? And now we just need to plug in the values. You've got the FD that comes out to be 6 pi eta RVT. Oh, you've got the drag force already. And that drag force is, or the viscous drag is 5.6 times 10 raised to the power of negative 5 divided by 6 times 3.14 times the radius, is going to be 0.62 times 10 raised to the power of 3 and 10 times the velocity. The velocity has to be 0.2 divided by 1.3. So you just need to divide them up. And by dividing them up, you'll get some viscosity that should be 0.0311 pascals second. So that is how you'll be looking for the viscosity. And now you've got the C part, right? The student repeated the experiment. He used the same oil at a lower temperature. So lower temperature, what does that mean? The liquid should be having a high viscosity. Explain how using oil at a lower temperature affected the time taken for the ball bearing to fall 20 centimeters. So everybody knows that whenever you're talking about lower temperatures, right? At lower temperatures, you must be having a higher viscosity, right? 3 mark question. So I'll make sure to write down at least 3 points. Higher viscosity means that the body should have a very small value of terminal velocity. The body should have a very small value of the terminal velocity. And thirdly, if you've got a very small value of terminal velocity, the ball bearing would take more time, right, to fall down. If because it is having a very small value of VT, right? So ball bearing would take more time to fall. So that is how we need to talk about all these things. Next, we've got this question number 7. A violin is a musical instrument that has 4 strings as shown. A force extension graph for a sample one of the strings is shown below. You've got this force extension graph. And then, you've got the table that shows the stiffness of the strings X, Y, and Z. We need to deduce that which string was used to obtain the force extension graph. So what does that mean? That we just need to calculate the value of K from the graph. You can all see that, you've got the force and the extension, and there is a Hooke's law that states F is equals to delta F is equals to K delta X. So if you want to calculate the stiffness of the spring, that has to be delta F divided by delta X. The change in the forces is from 0 to 80. That has to be 80 newtons. And the extension, it went from 0 to 30 millimeters, right? This is 30. So 30 millimeters, not 30 exactly, that has to be something like 29, right? So 29 times 10 raised to the power of -3. By dividing them up, you'll get the value of K. And by dividing them up, you'll get the value of K. And that comes out to be something like 2760 newtons per meter. So if you've got this value of spring constant, what does that mean? That the spring that you must have been using should have been Y, because that is the closest value that we can have, right? So we have got the spring constant or the stiffness, and that was 2760. So it was spring Y. It was spring Y. That is how we're going to talk about it. Now, in the B part, the fourth string on the violin has the original length. This is L, right? When the tension applied on the spring is 36 newtons, this is the force, right? The new length of the string, this is the new length, right? So by just taking them away from each other, you need to get yourself delta L, and whatever it comes out to be, that has to be the final answer. If you have got the radius, you can also calculate the area. And now you need to calculate the Young's modulus. And how would you calculate the Young's modulus? Young's modulus is the stress upon strain, right? So the formula would eventually become F times L divided by A times delta L. I'm just going to plug in the different values. I've got the load, and that is 36. I've got the original length, and that is 0.750. I can calculate the area by using pi r square. So 3.14 times 0.85 times 10 raised to the power of -3 square. And I can calculate the change in length by taking 0.750 away from 0.752. And after just solving all these things down, you've got the force, you've got the original length, you've got the area, and you've got the extension. After calculating all these things, you'll be able to determine the Young's modulus of this system. And that comes out to be whenever you're talking about Young's modulus, the value of this Young modulus has to be 5.96 times 10 raised to the power of 9 pascals. So that is how we're going to calculate this Young's modulus, right? Now we have got this question number 18, where we have got a set of these different spheres which are going to strike along each other. Each sphere has a radius of 7 times 10 raised to the power of negative 3 cube. Calculate the mass of one sphere. Density of the steel is given as well. So since the density is mass upon volume, so the mass has to be the density times the volume, right? So you've got the density, and that is 7.8 times 10 raised to the power of 3. And the volume of the sphere, that has to be 4 by 3 pi r cube, because you've got the radius and you need to calculate the volume of that sphere. So that has to be 4 by 3 pi r cube. So 4 by 3 times 3.14 times r cube. R has to be 7 times 10 raised to the power of negative 3 ka cube. You can just simply work this thing down, times them up together, and you'll get the final value of mass. That has to be something like uh, 1.12 times 10 raised to the power of negative 2 kilograms. That is how you're going to calculate the value of mass. Got it? Now, after this question, we have got something like student pulls the sphere A so that the string is at an angle of 38. So you've got an angle of 38 over here. I'm just going to complete the triangle. The direction of the acceleration would be, since it has got to its maximum position, the direction of acceleration has to be from here, right? So as shown, releases from sphere A. Determine the initial acceleration of the sphere A when released. So you just need to calculate the initial acceleration of the sphere when it is released. So what does that mean? It has to be a vertical component of the gravitational acceleration. So A initial acceleration of the sphere has to be, because we're looking for this component. This is the opposite side of 38, right? So you just need to use sine theta. So you've got 9.81 times sine 38. You just need to work this thing down. So 9.81 times sine 38 would be something like 6.04 meters per second square. That has to be this type of an acceleration, right? So now we have got this diagram number C. Well, we've got all these diagrams. Diagram 1 shows the position of the sphere when the sphere A is released. After being released, blah, 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 they all collide. BCD remains at rest. E moves away from the sphere D. Diagram 2, blah, 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 describes the changes in energy and momentum of the sphere A and E from the time sphere A is released until sphere E reaches its highest point. Ignore the effects of the air resistance. So we just need to ignore the effects of the air resistance. I'm just going to talk about it. This is a 6-marker question. First of all, I'm going to start with this point. A being at the highest mean position. When A was being at its highest mean, at its highest extreme, what does that mean? That initially A had maximum gravitational potential energy, right? Secondly, as it moves as it moves towards B, kinetic energy kept on increasing. Its kinetic energy kept on increasing, right? A had maximum momentum. It would be having a maximum momentum as soon as it is going to strike B, right? So, it would be having a maximum momentum as soon as it's going to strike the B. So now, kinetic energy of A should be transferred to E via the middle balls, right? Via B, C, and D, I guess. Okay. And now you need to you write down two very important lines, that since energy is being conserved, right? So energy input of A at B should be equal to energy output of E, right? Whatever energy you've transferred from A here, that must be the same energy when D gonna, make the E pop away. And at the same time, initial momentum, or you can just simply say the final momentum upon collision of A should be equal to the initial momentum of E as well. Well, remember that we're talking about the law of conservation and law of momentum, and both of them should be conserved. So you just need to write down these important points, and then at the end of the day, you need to talk about the relationship between the energy conservation and the momentum conservation of both these bodies. After this thing, we've got this question number 19. A student stores a bicycle on a rack. The bicycle rests on the rail that can rotate about a pivot to take the bicycle off the track, blah, blah, blah. They keep on talking about nothing. When the rail is in equilibrium, the principle of moment applies. What is meant by the principle of moment? Well, everybody knows that. For a body to be having summation torque is equal to zero, the clockwise moment, the total clockwise moment acting on the body must be equal to the anti-clockwise or counterclockwise moment, right? So that is how you need to be talking about these things, right? This is the principle of moment. Now, the next B1, a very important question, right? Now, what are they talking about? Now we've got the B part of the same question. We've got the bicycle off the track. The student lifts the rail back to its original position. We've got the original length of the track to be 1.40 and the weight of 95 Newton. So basically, we just need to calculate the minimum value of F needed to lift the rail off the ground. So if you need this force, we certainly need to apply the principle of moment. And whenever you're doing a question regarding the principle of moment, you need to identify the number of forces acting on that whole thingy. So you've got this 160 Newton, you've got this 95 Newton as the weight, and you've got this force. So we have got three forces. So first of all, we're going to calculate the moment due to these three forces. So the moment due to, for example, whenever you're talking about this 160, so the moment of piston about the pivot is going to be, I'm just going to calculate the moment. The force is 160 and the distance from the pivot of this force is 0.37. We're looking for this distance, right? So we've got 18 degrees over here. I'm going to take the vertical component of it, and that is going to be sine 18. When you're going to times them up, you should be having 18.3 Newton meters. So this is the torque due to the pivot. And now you have got the moment of the weight. So I just need to calculate the moment of the weight. And the moment of the weight is going to be 95 Newton, which is the force or the weight of the rod times. It must be acting at the center of gravity. Since the total length is 1.4, so the center of gravity should be at 0.70 from the one end. And then you need to times it by the angle through which it is subtended by the horizontal. And that is going to be cos 42. When you're going to times them up, you should be having something like 49.4 Newton meters. That is the torque due to the weight. At the end of the day, you've got the torque due to this force as well. This must be F times 1.4. So this F and that 18.3 Newton. Both of these moments are acting in a clockwise direction, and this one is going to be an anti-clockwise moment. So sum of these two moments should be equal to the other one. So 18.3 plus F times 1.4, it should be equal to the moment due to the weight, and that is 49.4. So I'm just going to work this thing down, and force must be equal to 49.4 minus 18.3 divided by 1.4. When you're going to take them away from each other, you're going to divide them by 1.4, and you'll end up having 22.2 Newton. So that is how you can calculate the force required to lift that rail up. Now you've got this second question, and in the second question, you've got the student could have lifted the rail by applying a vertical upward force to the handle. The force needed to lift the rail is different when the force is vertical compared with when the force is, well, for example, if you're applying a vertical force, if you're going to apply the force vertically, the moment of the force should be less. And if the moment is less, the force needed should be greater, right? The force needed should be greater. So for example, if you're applying the vertical force, what does that mean? That you need a higher or a greater moment, right? Greater moment, because the moment arm should reduce, right? If you need a higher moment, what does that mean? That uh, you know, if there is a higher moment, what does that mean? That the force required to lift that thingy up is greater as well, right? So that is why the forces applied along the perpendicular or along the vertical has to be different, because the moment arm changes. Now you've got this question number 20, and you've got the time, you've got the distance, and you just need to calculate the mean acceleration is 0.95 g. We just need to deduce that air resistance acting on the skydiver was negligible during the first 1.5 second, right? Air resistance is negligible if acceleration is greater than 0.95 g. So we just need to work out the acceleration. So I'm just going to use s is equals to ut plus half at square, right? S, everybody knows that s comes out to be 11. Initial velocity should have been 0, so 0 times t has to be 0. 1 by 2, I'm calculating the acceleration, and time is 1.5 squared. So by working out acceleration from here, it comes out to be 11 times 2 divided by 1.5 ka square, right? So I've got something like 11 times 2 divided by 1.5 square. And when you're going to sort this thing down, it comes out to be 9.78. And if you want to write this 9.78 in terms of g, just divide it by 9.81, and that comes out to be something like 0.997. So 0.997 g. So it is preferably 0.997 is greater than 0.95 g. Since if it is greater than 0.95 g, what does that mean? That air resistance can be considered negligible. So they're right in their assumption. Now, if you have got this VT graph, for example, you've got a displacement time graph for a skydiver between jumping from the aerospace and opening his parachute. And you can see that the displacement is decreasing in the negative direction. So the velocity, initially, you can see that the displacement was a curvaceous. So, the velocity would increase, but it should be in the opposite direction. And then as soon as the line becomes straight from 10 to something like 22 seconds, you know, it would be something like this, and then it would be a straight line, right? So that is how the graph of the vertical velocity should look like. In the BC part, you have got that after jumping from the aeroplane, the skydiver accelerated. And when the skydiver accelerated, then reached a terminal velocity before opening his parachute. Explain how energy conservation applies to the skydiver before opening the parachute. So when he is jumping downwards, what does that mean? First of all, the gravitational energy must be decreasing, right? The gravitational energy must be decreasing. And when the gravitational energy is decreasing, what does that mean? That the kinetic energy must be increasing, right? Because we need to conserve the energy, right? And if the kinetic energy is increasing, where the other type of energy is going, you need to do the work done. You need to do some work against the air resistance as well, right? You need to do some work done against the air resistance as well. Energy must be dissipated in this form, right? Now, as the terminal velocity is achieved, gravitational potential energy would be all gone, and you would be doing just work done against the air resistance, right? So at the terminal velocity, the gravitational potential energy has to be zero, and all the energy, I'm talking about the gravitational potential energy, it must be dissipated to do work done against gravity, right? That is what we all need to know about. Got it? Now, we've got something like D part. The skydiver opened his parachute and his speed changed. After a time, he reached a terminal velocity. Explain how the forces acting on the skydiver caused this acceleration. How this caused this acceleration to vary after the parachute opened. So first of all, remember that as soon as the parachute gonna open, you all know that air resistance should be bigger than the weight, right? Air resistance should be bigger than the weight. So what does that mean? That the resultant force is acting upwards, right? Initially, resultant force is acting upwards. And similarly, the acceleration of the body must be upwards as well, right? And when the resultant force is upward, the skydiver would start decelerating, right? Acceleration is upward, but skydiver should start decelerating. It would be some sort of a stationary thing up in the air. And after this thing, as the speed gonna increase, after this step, the speed gonna increase. At the same time, the air resistance would decrease as well. And as the air resistance decreases, what does that mean? That now the air resistance plus the upthrust acting on the body should be equal to its weight. And as soon as the upthrust and air resistance becomes equal to the weight, what does that mean? That now the resultant force should be zero and acceleration is supposed to be zero as well. So that is how the acceleration varies from him jumping down the thingy to parachute opening. This is the step when he opens up the parachute, and when there is some time, then this thing is going to happen. So that is how we're going to do this paper. I hope you've got every question of it. If you've still got any questions, you can comment, and I'll try to answer. Thank you very much.